Hello everyone, welcome to the oral defense of research on classification of Mandarin Chinese constructions. Today I'll be presenting the summary and the results of my thesis. Before we get started, I would like to introduce today's agenda. In the first part of this presentation, I'm going to talk about the motivation and research question. After that, I will briefly review some literature. About the experiment, I will first explain how data was collected and annotated. Then I will present the design and results of this experiment. Finally, in the conclusion part, the contribution, limitation, and future works of this thesis will be discussed. The widely accepted definition of polysemy is the association of two or more related senses with a single linguistic form. For example, the word school can be referred to a place where students go to be educated or a large number of fish. When a polysemous word occurs in a sentence, it gives rise to semantic ambiguity. In our daily conversation, semantic ambiguity can be explained by nonverbal behavior such as gestures or facial expressions. However, when machines are trying to understand a sentence, semantic ambiguity becomes an obstacle. Therefore, word sense disambiguation has always been a heated topic in natural language processing. Word sense disambiguation aims to determine the intended senses of words in text. Similar to words, constructions are also polysemous. For instance, examples of the construction 不 x 不 y can be 不明不白, 不中不西, and so on. 不明不白 intensifies the vagueness of something, while 不中不西 means something is neither Chinese-like nor Western-like. Considering the multiple senses of a construction, the goal of this thesis is to expand the disambiguation task from word level to construction level. It is found that semantic relations between two open slots, namely x-y relation, can lead to different construction senses. In the previous example, 不 x 不 y, when x and y are synonyms, it intensifies the degree of negating x and y, as in 不明不白. When x and y are antonyms, it means neither x nor y, as in 不中不西. The research question of this thesis is to find out whether relation-based representations can classify construction senses. To answer this question, we analyze construction senses with a corpus-based approach and performed a construction sense classification task with machine learning models. It is expected that by using relation-based representations, models can classify different senses of polysemous constructions. Before we dive into the experiment, I would like to provide a brief review of the literature. Construction grammar is a theory within the field of cognitive linguistics. According to the theory, constructions are four meaning pairings with high frequency, and they are stored as fundamental units in human brains. What's special about construction is that their meanings cannot be inferred from their constituent parts. This figure demonstrates the structure of a construction. The form of a construction consists of syntactic, morphological, and phonological properties. The meaning consists of not only semantic properties but also pragmatic and discourse functional properties. With a symbolic correspondence, form and meaning are linked together. In some cases, a form can be linked to multiple meanings, which is known as constructional polysemy. Goldberg explained the constructional polysemy by proposing a radial network of related senses. In the case study of caused motion constructions, the central sense is X causes Y to move Z. Other senses are linked to the central sense as a radial network. Later on, Torre challenged the idea of radio network by proposing that senses in a construction are related through family resemblance. He suggested that senses are connected by overlapping similarities instead of a central sense. In caused motion constructions, the senses share a general meaning, which is change of circumstances. The example below show that there are overlapping meanings among different senses, but none of them is considered a central sense. As far as we know, discussions of constructional polysemy are not as many as those of lexical polysemy in Mandarin Chinese. Therefore, we draw our attention to the four-word constructions, which include many in-depth studies. Zhou referred to these kind of constructions as quadrisyllabic idiomatic expressions. Some defining characteristics include four syllables or logographs, relatively fixed structure and patterns, and figurative meaning and semantic opacity. It is found that semantic relation between two slots in a QIE can lead to different construction senses. Liu et al. Concluded 5 different senses among 6 QIEs, including emphasis, overall, equivalence, contrast, and subjunctive. In the data analysis section, we adopt the 5 types of meanings to categorize our data. In the experiment, we will employ the relation-based representations to classify construction senses. In this thesis, we concentrate on four-word structures of reduplication, including a repetition of one constant and 2 different variables. Constants and variables can be in different positions as long as they are non-adjacent. We collected this type of constructions from contemporary Chinese construction database. We then matched construction forms in PDD corpus. First, we matched the constant precision, and then we checked the post tags of variables. Matches were retrieved along with their context. Forms with more than 100 matches were filtered to go through the construction analysis. We conducted a constructional analysis to compute the attraction between word pairs and the construction. The sample output shows the 5 strongest word pairs of E verb 1, E verb 2. Among the 5 pairs, 问答, 黑白, and 进出 are antonyms, while 站分享 and 搭唱 are parallel structures. After observing word pairs in each construction forms, 12 forms which accept different XY relations were selected for the annotation task. We compiled a construction dataset with 12 forms and randomly selected 100 matches from each form. Each data consists of form, match, and its context. After that, 2 annotators labeled the XY relation of each data. The inter-annotator agreement reached a kappa value of 0.75, which proves the substantial reliability. All kinds of semantic relations are listed in the table. It should be noted that relations were decided by context. If the construction match contains word segmentation error, it will be removed from candidate. Besides traditional relations, we added a category named parallel structure to decide the fact that X and Y have similar patterns or same level of importance, but not belong to any of the traditional relations. The bar chart here demonstrates the distribution of XY relations in each form. Some of the forms have dominant XY relations, which may be resulted from the semantic constraint provided by their constant. We adopted the 5 construction senses concluded by Liu et al. To categorize our data. The sample analysis provided here shows the XY relations and senses of 不 x 不 y. If xy relation is synonymy or near synonymy, the construction has an emphasizing sense as 不是任不是格 and 不吃不喝. When xy relation is labeled as entailment, it has a subjective meaning. For example, 不吵赢不罢休 means if one does not win the fight, he or she will not give up. When x and y are in parallel structure, it has no extended meaning. Therefore, we label them as literal meaning, as in 不习惯不喜欢. Aside from the 5 construction senses concluded by Liu et al., we added 3 categories, which are bare conditionals, in between, and resultative. Bare conditional prompts a sense of then in the consequent clause. In between describes the status that is in the middle of the two things. Resultative means the antecedent clause results in the consequent clause. Before moving on to the next session, I would like to provide a brief recap. Construction forms are forms collected from the construction database. Construction matches are instances of construction forms retrieved from PDD corpus. Finally, construction candidates are actually construction matches without segmentation errors. It may contain constructional or literal meanings. We created a balanced dataset with 5 relations by randomly selecting 106 samples of each category. After that, we split them into an 80-20 ratio. The 3x2 experiment contains 3 models and 2 input conditions. 3 models are logistic regression as a baseline, fast text, and BERT. 2 input conditions contains with or without weak supervision signals. Weak supervision signals are created by adding the target construction as a prefix and inserting brackets around the target construction. The results of the experiment shows that BERT performs better than others in both input conditions, and that weak supervision signals help increase the accuracy. In conclusion, contextual embeddings and weak supervision signals can provide information that help predict the XY relations. From the confusion matrices, we can see that back-of-words representations with logistic regression did not fully capture the semantic relations. Word embedding models, namely fast text and BERT, perform much better than logistic regression. Among the 5 semantic relations, entailment and synonymy are the 2 categories that can be best predicted. We performed an error analysis by inspecting each of the predicted results. We found out that in the results of fast text and BERT, most incorrect predictions were candidates without constructional meanings. It means that real constructions, which are candidates with constructional meanings, tend to be predicted correctly. Through the data analysis and machine learning experiments, we can draw a conclusion that models can categorize construction senses with relation-based representations. Among all models, BERT with weak supervision signals has the best predictive ability, reaching an accuracy of 0.8. The contributions of this thesis are twofold. First, it proposes a method of classifying construction senses with relation-based representations. Second, it proves that contextual embeddings can provide abundant information for construction sense classification. There are 3 limitations in this thesis. First, since the construction matching process was automatic, there were some false positives in the construction analysis. Second, since our data was limited, the construction census proposed in this thesis may not cover all kinds of constructions. Finally, the data was rather small for machine learning models. In spite of these limitations, it is hoped that this thesis can serve as a basis for future research on construction census. As for the future works, we hope to increase the size of the construction dataset. Considering the laborious annotation task, it will be more effective if the semantic relations can be determined automatically. We tried computing the sign similarities between plots with fast text embeddings and see if they can help determine the relations. However, this first attempt failed since the word embeddings are generated from the vocabularies of original context. We are hopeful that future works will provide more practical methods to automatically decide the relation between plots. Finally, in the future works, we can add more linguistic features such as post-text to improve the model performance. This is the end of my presentation. Thank you.